Hi, and welcome back to the R Bootcamps. You have graduated Module 1.1, and we're moving on to Module 1.2, Managing Data. So that's Bootcamp 1, Module 2, right here, Managing Data. And just like any other module, when we start a module, what we do is get the script for the module so we can work through it in RStudio. So that's the first step, is just to right click or command click, save this link in your Bootcamp folder. All right, so take a minute to do that. I saved mine in my desktop in a folder called R Bootcamp, and I'm going to save this. It should be called module1_2.r. That means it's an R script, and we'll save it to that directory, which is our working directory and our project directory. So take a minute to do that, and we will go right into RStudio. But remember, the website's here for you to check back, and if that helps to learn outside these videos, it is a resource that's there for you. But we're going to go into RStudio. So if everyone could open up RStudio. Remember, last module we made a R project, or RStudio project, for this bootcamp. So I would recommend going in and getting into that project again. It's really helpful to work within RStudio projects. It makes it a lot easier to work with data and to manage different projects, for instance, and to share our projects with other people, collaborators that we may be working with. So one way to get to our project is just to go into the File menu, go to Recent Projects, and open up the R Bootcamp project, or whatever you happen to name your project, and open it up. So that's one way to do it. The other way is to go into your project folder and find the rproj file, and double click or open this file, and that will open up the project. What this does is it automatically sets that folder, that directory, as your working directory, and so it's automatically going to look for data files and scripts in that directory, and you don't have to worry about setting your directory, or when you are working with someone else's code, to comment out their working directory and set your own. We'll talk about working directories in a minute, but it'll make your life a lot easier to use the RStudio project. All right, so now that you're in the project, open up the script for this module. To do that, go to the folder icon here and find module 1_2.r. That's the one we're going to be running through in this video. And this module is all about managing data. So we're going to read in some data files, and we're going to work with data and manage data, meaning working with missing data and dealing with some other data issues that we may need to do before we can get ahead and do real statistical analyses. So oftentimes data need to be managed before we can do analyses. In fact, in a typical workflow, or data analysis workflow, much of the time that you spend in the project is actually going to be in that early stage of just getting the data in the right format, making sure there's no typos and weird things in the data. So, once you get to the stage of actually running analyses, it can be fairly straightforward and quick, and doing visualizations and that kind of thing. So oftentimes it's the data management stuff that really takes a lot of time, probably more time than you think it's going to take. So that's what we're going through here. Like I mentioned earlier, one of the first things we need to do in many cases is we have to think about the working directory, because if we're going to read in data, that's an external file that we have to connect with R. R has to read in this data, and so therefore R has to know where to find it on our computers. And every computer obviously has a different file structure. We specify our own file structures that make sense to us. So, we have to tell R where to look for things. So every time we open an R session, whether we're working in an R project or whether we just opened up our studio for the first time, there's always a default working directory. Since you're in an RStudio project right now, your working directory is going to be your project directory. And the way to find out what your working directory is to use this get wd function, or get working directory. This just tells us, and let's run it. Control Enter to run this line. That'll tell us what our working directory is. And by that I mean that's the directory that R is going to look for any data files by default. So just verify that that is the case. Now if I just opened up RStudio for the first time, it might look something like this, and there will still be a working directory. It's just the default that R or RStudio decides it should be. So if I did get working directory here and typed it into the console, I have to do open close parenthesis to tell R that this is a function. And in my computer, in a Windows machine in general, it's going to be the documents folder, but in other operating systems it might be something different. But it's useful to know that no matter what, you always have a working directory. You might not know what it is, but you can get it, you can find it using this get wd function. We've gone through how to get your working directory, figure out what it is, but let's figure out how to set your working directory. Now you may need to do this by using RStudio Project. We're trying to avoid the need to do this a lot, but it's useful to know that you can set your working directory. There's a couple of ways to do it. One way to do it is to go into your RStudio, go into your session, the session menu, and click on Set Working Directory, and you can just go to Choose Directory, and that'll pull up a navigation window, and you can navigate to whatever folder you'd like to specify as your working directory. So that's one way to do it within the RStudio environment. Another way to do it, I'm just going to uncomment out. Now when I put a pound sign or a hashtag before a line of code, that's called commenting it out, because remember, once I've added that hashtag, R is not going to do anything with it. But it's easy to reactivate that line of code by taking that hashtag away. And so if I wanted to set my working directory within my script, which can be a useful thing, I can just insert whatever the file path for my working directory is right here. There's a couple of things to know about setting working directories that can be annoying, and it's annoying especially when you're working with different types of operating systems. So when you're working with Windows, I'll show you what this is about and why it's kind of annoying. Let's go to the Bootcamp folder, and I will copy the file path right here as a text. I'll just copy it and I'll insert it into this set working directory function. So I'm going to try to set my working directory to the project directory manually. Now I could set it to any directory, but I'm just going to reset it back to the project directory, and I can run it. Control Enter to run this, and it tells me there's an error. What's going on? Well, what's going on here is that Windows likes to use the backslash for file paths, whereas R is originally kind of a Unix-based program, and it uses forward slashes. So you have to change them all to the forward slash. So there we go. So that's one thing. If you change all of these slashes to forward slash and hit Control Enter, then it'll run. Yay. The other thing you can do is double backslash. So useful to know, annoying, but useful. Double backslash works as well. There we go. So we've set the working directory. Now, if you ever set the working directory and you want to return to the project directory, another thing to do is just go up to the session, set working directory, and then return the working directory to the project directory. So lots of different ways to do it. Can be really annoying, but if you use RStudio projects, it's a lot less annoying. So I think that's all I really want to say. Now, another thing you can do is do this choose directory. So it basically is the same thing as going up to the session menu and choose directory here, but you can embed that in the script here, and it'll automatically give you a browser to find a directory that you'd like to set your working directory as. Not that important. I'm going to comment that out. All right. And that's always a good thing to know, is you can comment things. You can comment out whole blocks of code if you'd like. I could, for instance, just if I wanted to comment out a whole block, there's actually a shortcut in RStudio that allows you to comment things out. It's Control-Shift-C, and that just puts comment symbols before everything. Don't feel like you have to memorize that, but if you are interested in some of the shortcuts that RStudio has, you can find out more by going to Keyboard Shortcuts Help, and there's a whole bunch of shortcuts, including Control-Enter that we've been using, but there's a million others that are really useful. If you're working with RStudio a lot, I recommend learning some of these shortcuts. All right. Let's get back to the script. Here we get into something that is really important for all of us who work with data, is actually reading in data into an R session. So we've learned how to set objects. We can make our own objects. A is assigned the value 1, and we have this object A in here. But we want to get a whole data set in, and we don't want to have to type it all in because it's probably already in a comma-separated file or an Excel file or something. So let's read in some data. Now, to read in data, obviously we need some data set to read in. So let's go back to the Bootcamp website where we can download some data to work with. So if you scroll down to importing data into R, where it says download the following data files and store them in your working directory, let's download these data files and store them in our working directory. So I'm going to right click, save as, and save these files into my working directory. So I'm going to save this. And before we read them into R, let's actually look at them. So let's go into our working directory, and we see that there's a couple data files. Let's first open up data.txt. Here's a data file. And it's important to note what the separator is, like what's separating each data point or piece of information from another piece of information. And here it looks like it's a tab delimited file or a space delimited file. This should be a tab delimited. So looks like we have a data set with 4 columns: country, import, export, and product. And looks like it's separated by tabs. So there we go. Let's look at the other data set. This is data.csv. We can either open it up by default. I think many of you will see that the CSV files will open by default in Excel. If you don't want to open it in Excel, you just want to see, because these are just text files. If you open it in Excel, it'll look like a spreadsheet, but it's not really. It's actually a text file. It just will open in Excel. So let's open with a text editor. I'm going to open it in Notepad in Word, so you can see what this file really looks like. It's just a text file, but and it's very similar to the other text file we opened, except that instead of a space or tab delimiter, it's using a comma, and this is a really common way to read in data. It's called a comma-separated value file, or CSV. So I wanted to give you an example. That's the common CSV format. Still probably the most common way to read data into R. All right, so we have data sets, and we've saved them in our project directory, which is really important because that'll allow us to easily read these files into R. So let's do that. Go back to your project, RStudio project, and let's read in some data. All right, so we have a couple data files. We have data.txt and data.csv. What we're going to use here is the generic data reading function read.table. All right, if you want to learn more about read.table, you can uncomment out this line of code and Control Enter or Command Enter and learn more, because use that question mark to get the help file. The help file will come up here and you can learn more about reading in data. All right. Read.csv is a version of read table that actually is specialized to read in CSV files, so it just makes your life a little bit easier if you're only working with CSV files. All right, so let's move on to reading in data. So we're going to use read table. That's a function, so it's going to be followed by a parenthesis, and we're going to give the read table function the name of the file we want to read in. We're going to tell it that that file indeed has headers. It has the top row is the name of each column, so that is header is true. And we have to give it what the separator is, whether it's a tab delimited file, a space delimited file, comma delimited file. All right. So if you put sep equals open close quotation, what you're saying is that the delimiter is any one of a set of common delimiters, including spaces, commas, and tabs. So it's a useful way to, if you know it's a common delimiter, you don't have to specify what the delimiter is. You just give it the open close quotation marks, and that'll tell R that this is a common delimiter. Let's read it in. If you Control Enter and read that in, we now have a data object in our global environment, our working directory. So here we go. If we hit that down arrow, it'll give us kind of a summary of what's in there. We have 4 columns. We have country, which is a factor variable. We have import, which is integer, export, which is integer, and product, which is also a factor. So we can learn a little bit about the data just by looking at it there. Let's read in the CSV file. This time we're going to give read table the argument, this is the name of the file we're reading in, data.csv, so we have to tell it what file, header is true, and now we're going to say separator is comma. So let's read that in. There we go. It looks like it read in. Let's just make sure. So we see it is exactly the same as the other data file. It just happened to have a different separator, but otherwise everything's the same. What would happen if we say sep equals open close quotation? We have 20 observations of one variable. So, in fact, comma is not included as one of the default separators. So you did actually have to specify that comma is the delimiter. Otherwise, it's going to read it as a single column here. So if we look at data.csv.df, it's all read in as a single column, and they're all read in as characters or factors, and you see the commas are just part of that. So it's actually not recognizing. So I did misspeak earlier when I said that comma was one of the default separator values. It is not, because we just tested it. So always a good idea, if you think something is true, just to test it and make sure that it is true. Easy to do, and it's a great way to learn as well. It's just to try things out, and you'll make mistakes, and making mistakes is exactly how you learn. So, all right, let's read this in now with the correct separator. Good, and now we're back to having the proper data set. We can do any number of data summary or visualization functions we want. We went through a few of those last time. Just to get the column names, we can use the names function. If we wanted to get a summary, we could do summary data.csv.df. I'm just going to use the autofill feature here so I don't mistype it. And there we go. So we get a nice data summary for each column. We can see what sort of values that are there and what type of variable it is. We can do a lot of other things. We could do the structure data.csv.df and get more information, although that's exactly what we get up here. So it's kind of redundant. All right. Let's look at the default function for reading in CSV files. It just makes life a little easier if you're working with CSV files, as many of you will be. If you have a CSV file, data.csv, we can just use the read CSV function as a shorthand to read that in. And now we have something called data.df, which gives us exactly the same thing as we've already read in. And use the names function. Let's, now that we have 3 redundant versions of the exact same data, let's get rid of a couple of them. You can use the rm function to remove a object from your global environment. So let's do that. We'll remove the data.txt, data.csv, so we just left with data.df. All right. Now, what's the class of this data object? We can test it out, but try to make a guess, because we know what the most common data storage object in R is. And that should be what this object is, data.df. It is a data frame. So remember, data frame is just a type of list object where every column is a different list element. They can be different types. Not every list element has to be the same type, but the only thing is they have to be the same length. So if one column is a vector of length 20, then all of the columns have to be a vector of length 20. All right, let's look at a couple other ways that we can acquire data or get data into our global environment. Okay, one way is, it's kind of cool, is just to load data directly from the internet. So if we know the URL for a data set, in this case it's this, it is freely available online. You could type it into a browser, and you should see that it's, if you type it into the browser, it's just going to download. So you could download it into your working directory here and then access it with a read.table call. Or you can read it directly in your R session, which is kind of cool. So if you go back to your project, we could just use this read table function and give it a URL and it'll read in automatically. So let's try that. We're going to read in this, and honestly I don't know much about this data set. I just picked it randomly from the internet, but it's something about the brain. And let's look at the head. So it looks like it's brain weight to body weight for a whole bunch of species. You can use the dim function if you want to know the number of rows and columns in the data set. If you type in the name of a function, it just gives you some information about what you're calling, but it's not actually calling the function unless you include that the parenthesis and any arguments that the function requires. So let's do that again. Okay, so it tells us that this data set has 64 rows and 4 columns. And of course, you could also do the nrow function to get the number of rows, and that can be helpful too. Okay, another way to get data, if you just want to practice with different methods, is using R's built-in data sets. We've already seen a couple of these, but if you use that data open close parenthesis function, it'll just automatically provide a list of all the built-in data sets that R has, and so you can look at them and go ahead and check some of them out if you'd like. There's a lot of good ones. I like to use the trees data set. Sometimes it's a real basic data set with just the tree volume and height and girth. So good for just playing around with regression models and that kind of thing. But there's a lot of data sets. We'll look at the iris data set in the next module. And anyway, feel free to explore these. Here's an example. We can control click here and read in a data set that's built in called MT cars. This is a data from road tests that were performed by Motor Trend sometime in like the 80s or something. We can read more about it, obviously. Use the question mark MT cars and you can read more about this data set. This is, so it's from 1974. But anyway, it's still a kind of a useful data set. We can look at the structure and learn more about it. Obviously, a bunch of information about a whole bunch of cars. Looks like 32 cars. We have 11 different measurements that are taken, including the fuel economy and the displacement and all sorts of fun things. And we can, again, try to do regression models, maybe try to model fuel economy as a function of engine size and things like that. But anyway, built-in data sets, the point is, are there and they're really useful. All right, that's all for reading in data. Let's look at what we do with data. So in general, a workflow consists of reading in data and then doing some data checks. So just making sure that everything read in properly, and then followed by some maybe basic visualizations, and then maybe a statistical analysis, and then maybe building some figures that illustrate the results of that analysis, and that might be the end of your workflow. But where we are here is just checking the data to make sure everything read in properly. So we can use the class function to tell us what we did read in. This should be a data frame. We already checked that. We can use the structure to look at the data. We've already seen that. Head is useful because it just displays the top few rows of data. So again, it just provides us a confirmation that everything read in properly. Now we can check that, yep, this looks right. We can use the head function. If we don't, the default is it'll print out 6 rows, but we could print out 2 rows if we want. We could print out 10 rows if we want. So we can also check the last few observations, and that can be useful as well. Sometimes just by mistake, R will, or Excel will save a whole bunch of like extra blank rows at the end. So just check to make sure that's not the case. And everything looks good here. We have real data at the end. We have real data at the beginning. Everything looks good. And there's the summary function again. All right. So we can verify at least here that the data were read in properly. Exporting data. We've talked about reading in data. Let's talk about writing data. So oftentimes, we'll do some data manipulations within R. We might want to write another CSV file based on what we've just done in our R session, and we might want to share it with other people. The way to do that is using the write.table function, or one way to do it. Very similar to read table, except it's doing the opposite. So you give it a data frame that is in your working directory. Here we're giving it data.df, but we're actually only giving it the country and product columns. So remember, when you index a matrix or data frame, You use the brackets and you specify the rows before that comma and then the columns after the comma. So this should evaluate. If I highlight this and hit Control Enter, this will evaluate to just the data with only the country and product column. So we're going to give the write table function this data to write. We're going to give it the file name that we want it to write, and if you want to guess what folder it's going to write to, which folder would it be? Obviously, it's going to write to the project directory. So if you don't specify another file location, it's going to, by default, either read or write everything to the working directory, which in this case is the project directory. We're going to tell it that we want to make a comma separated file, so the separator here is going to be a comma. We're going to write out the column names. We're not going to write out row names. And if you want to learn more about the arguments for write table, obviously just question mark write.table, you can learn more about it. Let's run it. And obviously you don't see anything happen here, but this function, its only job is to write out what's in an R data frame object to a file. So let's look at our working directory, and we see that we have this new data file called data._export.csv. So we just exported this data to our working directory. Let's look at it. Again, you could open it up by default in Excel, but I'm going to open it up in a text editor so that we see that this is really just a text file. And we see the two columns, and the separator is indeed a comma, so it worked. So that can be a useful thing, to be able to write data to file. Sometimes we don't necessarily care to write our data objects to a readable file like we just did. We exported to a text file that could be readable by Excel if we want. What if we just want to save some objects to read into another R session? We don't care that it's human readable necessarily, or that it's a text file that another program might recognize, because all we're going to do is read it back into R. In that case, what we can do is use the save function, which saves a binary version to your hard drive of any data objects you'd like. So here's all I have in my working environment. I can save any of these objects to a file using the save function. Let's make a few additional objects. We're gonna make an object called A, and it just stores the value 1, which actually it already done. And B is going to be the column from data.df that stores the product. So using that $, remember, just is a way to access a column of a data frame. And as you recall, if you type out the name of a data frame and then hit the $, RStudio will automatically give you a choice of which column to select. So I can select the export column, and I'll save that export column as a vector, and that name of the vector will be B. So there we go. B is now an integer vector of length 20 with those values. And now I'm going to save the A and B objects that I just made into a file called module1_2.rdata. So using the save function, again, you don't see anything happen, but the purpose of this function is to write to a file. So let's make sure that the function actually worked. Here we see module1_2.rdata. If you tried to open this up in a text editor, you'd see complete jargon. It doesn't mean anything because it's not readable by other programs. It's only interpretable by R. So the way to get those objects back. So let's say we remove objects A and B from our from the workspace or the global environment. See, they're no longer there. If I wanted to start working with them, there is no object called A because I just removed it. It's not accessible anymore. let's say I want to work with that object. Well, I can reload it back into my workspace using the load function because I already stored that object to the hard drive using to a file with this name. And generally, any data objects that are stored like this using the save function are stored using the .rdata file extension. So let's read the A and B objects back, and there we see they reappear into our working directory and we can work with them now. So if I run that, we see that A exists and B exists and life is good. So that's another good way to store objects for use later. Sometimes it might you might have a function that takes hours or even days to run. You really want to make sure you save the results of that to the file, because if something goes wrong, if your computer crashes or whatever, you won't lose it. You can just read it back in because it's stored in your hard drive. So really important to know. A few other good things to know here is how you would save everything in your working directory. So say you wanted to save all the objects that are here in your global environment. To do that, you can use this nice handy function called save.image, which automatically stores everything in your working directory. You just give it the file name. I'll call it module 2, and it'll save everything in my workspace to the hard drive. If I remove everything, I can use this rm function to remove objects, and if I feed into that remove function everything in my working directory, so ls just lists everything in my directory, I give the rm function the list of everything in my working directory. That will remove everything from my working directory. Let's run it, and it's gone. Everything's gone. If I want to get it back, I have to use that load function again, and now I'm going to use that module2.rdata, which stored everything I had formerly in my working directory, or in my global environment. I'll load it back up, and there it is. So everything's back. All right. So useful to know. Let's stop there. And in the next video, we're going to pick up with work with managing data in terms of identifying rows of a data frame that meet particular criteria, and fixing missing data, and doing some basic data management.